Hi guys, this is Mrs. Allison. Today we are going to start our next unit, which is going to be a systems of equations unit. So today we're going to do some basic definitions of systems of equations, some phrases you probably didn't hear back in Algebra 1 when you did systems of equations, and then go into graphing. All right, so let's begin. What is the definition of a system of equations? If we were to define them, what would we say? Well, we would say that a system of equations is a set of two or more equations. So a set of two or more equations. Okay. So what does it mean to be a solution of a system of equations? What does that mean? Well, it means that it's a point that makes both equations true at the same time. Both equations true at the same time. That's important. Because by very definition, a line is a set of solutions. Every single point along a line is a set of solutions. So the point where they are both equal is the solution to the system as a whole. Now, there are two types of systems we're going to look at. Actually, really three types, but one has two subtypes, if you will. So we have consistent systems. The definition of a consistent system is that it is a system that has at least one solution. We're going to expand on this. So that means an inconsistent system has no solutions. Okay, so consistent means has at least one solution, and inconsistent means has no solutions. Now we need to define consistent systems a little bit more. It actually has two parts to it. Okay. So the first part is that there could be an independent system. It's under the heading of a consistent system, but it's called independent. Independent means that we have one solution, only one. And you can see that consistent system says has at least one solution. So it can have one, but it can have more. All right, well, the second type of system that comes from a consistent system is what we call a dependent system. And a dependent system has infinite solutions. Okay, so consistent system has at least one solution. There's two types, independent or dependent. Independent is one, dependent is infinite. Okay. Whereas inconsistent just means has no solutions. There's really no other option besides that. Okay, well, let's look at solving systems by graphing, keeping in mind that a solution is a point that makes both equations true at the same time, and what it means to be the different types of solutions of systems, because we're going to look at that. Okay, so to solve a system by graphing, if you recall, the first thing we actually just need to do is graph each line separately. So I'm going to graph y equals 3/2 x plus 4. We'll graph that in blue. And this isn't a linear equation. So I'm just going to go ahead and graph, assume that you know how to graph this. So I'm going to start at 4, and I'm going to count up 3/2, and I'm going to graph it. One of the things you're going to see about graphing systems of equations is you want to continue your graph almost the whole way across the graph paper, because you never know where the solution's going to lie. So there's that line. Now I'm going to graph y is equal to -1/2 x minus 4. So -1/2 is down 1, over 2. Let's erase that second dot. Down 1 over 2. And I can see right now, I know which direction this is going to intersect. Oops, I can count. So I know which direction this is going to intersect. So now I'm going to graph it. Now, remember we said that a solution makes both true at the same time. Both equations true at the same time. Now what I know is every point along a line is considered a solution to the line. So for example, if I plugged in 0, 4, 4 equals 3 halves times 0 plus 4, it's a true statement. Every point along this line makes a true statement. So when I look for where they're both true at the same time, what I'm looking for is where they are both equal, where they intersect. That intersection point is my solution. So in this case, I have a consistent system, meaning it has one solution, but more specifically than that, this is an independent system. This is an independent system, and the solution to this system is the point at which they intersect. So this solution is -4, -2. All right, looking at this next one, I'm going to have you hit pause in just a second, but looking at this next one, can I graph it in the form it's in? Well, I can the first line, but can I graph the second line in the form it's in? No, I need to get that into a graphable form, into y equals mx plus b will probably be the easiest one. So why don't you hit pause and work to solve this system of equations? Okay, hopefully you had a chance to graph this. So I'm going to graph this first one in blue. So +2 up 3 over 1. I'm going to go down 3 over 1 as well. So when I graph this line, not a great graph, but there we go. And then now I need to go through and solve this other equation to get y by itself. So I'm going to do 6x minus 2y equals -4. I'm going to subtract 6x from both sides. I like to put the x in the front so it looks more like y equals mx plus b. So I'm going to write -6x minus 4. And then I'm going to divide everything by -2. So we get y equals 3x plus 2. Well, y equals 3x plus 2 is literally what I just graphed. Okay, so when I sketch this line, these lines lie right on top of one another. Well, this is an example of a dependent system. And the solution to this, what we write for a solution, is infinitely many solutions. Because every single point on the line, remember the line that continues on forever, is a solution. So one solution is -1, -1. One solution is 0, 2. One solution is 1, 5. One solution, and then all the little points in between, every single one of those is a solution. So this is a dependent or infinitely many solutions because they have the exact same equation. They lie right on top of each other. And if the solutions where they intersect or where they're both true, they're true everywhere along their lines, everywhere along their lines. All right, let's keep going. Can we, without graphing, determine whether the system is independent, dependent, or inconsistent? If you need a reminder, independent means one solution. Dependent means infinitely many solutions. And inconsistent means no solutions. Okay, so we just saw an example of a one solution and an infinitely many solutions. What was true about the infinitely many solutions? Right, it was the same line. Okay, well, if we're going to have no solutions when I'm graphing a system of equations, what do you suppose that looks like? Hopefully what you said is we're looking for parallel lines. Why? Because if the solution is where they intersect, the only kind of lines that never intersect are parallel lines. So let's look through these. First one, we're going to need to solve for y. So let's take this first equation, 4y minus 2x equals 6. And let's get, we want to solve for y. Let's get y alone. So I'm going to add 2x to both sides to get 4y equals 2x plus 6. I'm then going to divide by 4. And I'm going to divide each term independently so I can see them each separately. So we get y equals, let's reduce this, 1/2 x plus 3/2. Now, if it's going to be inconsistent, it's going to have the exact same slope, but if it's going to be dependent, then it's going to have the exact same slope and y-intercept. So let's see what happens here. Let's try this next one. Let's do it in green. So if we solve 8y equals 4x minus 12, and I divide by 8. So if I divide by 8 here, I'm going to get y equals 1/2 x. Now, if I do this, I get 3/2. Well, this is real close. Is this what we just graphed? Are these the exact same line? No, these are not, but not by much. If you look, their y-intercept, same value of number, but one's positive and one's negative. So this would be an example of parallel lines. So this would be an inconsistent system. Okay, so hit pause and try the next one, and then come back and check and see if you were right. Okay, so hopefully you went through and you solved this. So we have 2x plus 3y equals 1. We're going to get y by itself. So we get 3y equals negative 2x plus 1. Divide by 3 everywhere. So we get y equals negative 2/3 x plus 1/3. Okay, let's do the next one. Let's do 4x plus y equals negative 3. I'm going to minus 4, whoops, that was supposed to be an x, minus 4x. So we get y equals negative 4x minus 3. And I don't need to do anything else. So looking at this one, I have a slope of negative 2/3 and a slope of negative 4. Are they parallel lines? No. Are they the same line? Very obviously they are not the same line. Therefore, there has to be only one solution, and therefore this is an independent or consistent system. Okay, so we really focus on the slopes first and then move to the y-intercepts, but we're good here. This is pretty simple. All right. Now, hopefully there's some new information in there that you haven't seen before with systems. I didn't spend much time on the graphing systems of equations because you've done that for several years. So your assignment today is going to cover some of the graphing and then some of the new terminology that we're working on. So have a great day, and we will see you tomorrow. Oh, and don't forget your Math Excel assignment.